Lesson 76, consecutive integers. This is the first of two lessons we didn't get to in class today. Or on Thursday. So let's do this lesson. This is a good one for me to do on the computer because they're word problems. Consecutive integer problems are not difficult word problems if you know how to set up a thing called a heading. So first of all, let's talk about what a consecutive integer is. Consecutive integer would be like 1, 2, 3. They're consecutive. They're in order. 4, 5, 6, 7. They're one after another. They're consecutive. So when we do these consecutive integer problems, the first thing we have to do is learn how to set up our heading. So here's how we set up a heading. We pick a variable, of course, and we're going to use n for consecutive integer problems, just because we're talking about numbers, integers. So what we do in our heading, they're going to do the same for all of our consecutive integer problems, is we're going to say n is the first integer, first number. Let's read the problem first. Find three consecutive integers such that the sum of the first and the third is 146. So we're going to need three consecutive integers. So when you're going to set up your heading, your first, n will be your first number. So if we're talking about consecutive integers, if we have the first one is 2, the next one will be 3, right? So what we're doing is to get the next consecutive integer, you take whatever the first number is and you add 1 to it. So your second consecutive integer would be n plus 1. So you can see that up here, like if it's 5, in order to get to 6, we would add 1 to 5. So then we need our third consecutive integer because there's three consecutive integers. So in order to get from 1 to 3, how many do you have to add to that? To get from 1 to 3, you have to add 2. So to get our third consecutive integer, we'd say n plus 2 equals our third consecutive integer. This right here, what I have, is called our heading. You have to do this for consecutive integer problems. If you do, these problems are really easy. So your n is your first integer, n plus 1 is your second integer, and n plus 2 is your third integer. So if n was 5, you would add 1 would be 6. If you would add 2 to 5, you would get 7. So it would be 5, 6, 7. So once you set up this heading, which will be the same for all consecutive integer problems, then you just follow along with the words. Find three consecutive integers such that the sum of the first and the third, so here's the first and the third, since we have a heading, it's real easy to find what the first and third are. The sum of the first and the third is 146. So sum means addition. So we're going to add together the first and the third. So we have n plus 2, because that's our third, is n plus 2, equals 146. So you set up a simple equation. We add the like terms. 2n plus 2 equals 146. Subtract 2 from both sides. We get 2n equals 144. And then finally we divide both sides by 2 and we get 72. So our first consecutive integer is 72, and they want three consecutive integers. So we have to go over to our heading. The first one would be 72. The second one would be 73. And the third one would be 74. These are really easy to check. If this one plus this one adds up to 146, then we have a right answer. So 72 plus 74 does indeed equal 146. So we got it right. Let's try the next one. That one was super easy. Next one will be a little bit harder. This one says find three consecutive integers such that twice the sum of the first two is 2 less than 3 times the third. This is where a heading comes in really handy. So the first one, n equals the first. Let's put first. N plus 1 equals the second. N plus 2 equals the third. Now tomorrow we're going to do consecutive odd and consecutive even. This is just for plain consecutive numbers, like 72, 73, 74. They're numbers in order. So find three consecutive integers such that twice the sum of the first two. So So this is tricky. It's twice the sum of the first two. Here you need parentheses because it's twice a sum. So it says the first two. So here are the first two. So that'd be n. We want the sum of the first two, n plus 1, is, so we got our equals, is 2 less than 3 times a third. So it'd be 3 times a third. Third is n plus 2, right? Use your heading. This is your third. 2 less than 3 times a third. If it says less than, you always subtract it off the end. Like if I say to you, what's 2 less than 12, you're going to subtract 2 off and get your answer. You would never say 2 minus 12. So anyway, I hope you understand how we put that equation together. We've done that before. So it says sum of the first two, so here's the first two, sum of the first two, 2 times the sum of the first two is equal to 2 less than 3 times the third. So here's the third. This is 3 times the third. So then we're just going to solve this. This shouldn't be hard. Plus 1, I do inside my parentheses first. And I may as well distribute while I'm at it. Distribute the 3. And then we're going to distribute the 2, or n plus 2 equals 3n plus 4. Add like terms. I'm going to put my n's over here, so I'm going to subtract 3n from both sides and get n. And I'm going to subtract 2 from both sides and get 2. So we're going to get n equals 2. You're not done yet. You want to go back up and get your, it's asking for 3 consecutive integers, so you have to go back up. N is 3. N plus 1 would be 4. N plus 2 would be 5. So that's how you do consecutive integer problems. We're going to do one more example. This one is find 4 consecutive integers, such that 6 times the sum of the first and the fourth is 26 less than 10 times the third. So what's the first thing we do in consecutive integer problems? We need to set up our heading. So it's the same, but this time we have 4. So we're going to have n equals the first, n plus 2 equals the second, n plus 3 equals the third, n plus 4 equals the fourth. And I messed up. That was bad. Let me erase all these. What did I do wrong? You want to see that? The first one is n plus 1 equals the first, equals the second, sorry. N plus 2 equals the third. N plus 3 equals the fourth. So n plus 1, n plus 2, n plus 3. Now we follow along with the words of the words in the problem. It says 6 times the sum, so we need parentheses, of the first and the fourth. So we need the first and the fourth. So that'd be n, the sum, plus the fourth is n plus 3, is 26 less than, so we're going to put that down here, 26 less than 10 times the third. The third is right here, so it's n plus 2. As far as I know, we didn't even use the second. First, fourth, and third. So now we have it down into a simple equation we'll solve. So we get 6. Do inside parentheses first. 2n plus 3 equals 10n plus 20 minus that less than 26. Distribute again. 12n plus 18 equals 10n minus 6. All the n's on one side, so we'll subtract 10n from both sides, so we get 2n. And I'm doing this all in one step, and we'll subtract the 18 over here, equals minus 24. So we're going to get n equals, divide both sides by 2, negative 12. No, first time we had a negative. So let's see, we have to go back up and find the rest of our answers. So we have n is 12. Now we're negative 12. Now we're going to add 1 to it, so it's going to be negative 11. Now we're going to add 1 to negative 11, get negative 10. And then finally we're going to get negative 9. You can check to see if this works. Find 4 consecutive integers such as 6 times the sum of the first and the fourth. So 6 times the first and the fourth is 26 less than 10 times the third. And then you can see if this works. So you get, you can just put this in the calculator if it works. So that's how you can tell if it works, if both sides are equal. So that's about it for consecutive integers. If you have any questions, please go on the help board and ask me. Don't get lost. If you get lost, you're responsible. You can go on the help board anytime and I'll answer your questions. So that's it for lesson 76.